this end, and now I go full screen. Okay. All right, we're ready to get into our lesson for prerequisites for quadratic equations, right? We did some exercises last lesson of expanding expressions and factorizing as well. I'll go really quick, just give you a couple of examples on these two topics. First of all, we'll start with the expansion, so expanding. So fill in expanding. Okay, and I'll just start with the very 5 key common mistakes that happens in this type of So much for not interrupting my lesson, huh? No, I don't need to because I'm recording the screen. Yeah. All right, I'll try to cut this bit out, yeah? And I think it's going to go off soon. So let's start with 5 key areas of expanding situation. Obviously, we are very familiar with expanding. Right? There are some models that we can use. First of them is when we have an example of, for example, x times whatever it is, right? A plus b. And I'll write it in generic form. So these could take any number. You already know that, right? So if I wanted to expand this form, and I'm going to use red pens, I say, okay, well, the first technique was the foiling, right? It was basically the distribution or distributive law when I take x inside this bracket. So it happens when I just go a times x, obviously x times a, same thing, plus then x times b or bx. That's a very simple, very basic, right? And then from there, we had some examples. If I have, for example, in this form, and I'm going to write 1 next to it, 1, first of all, if I have, I'll just put common mistakes, right? Maybe mistake number 1, common or key mistake number 1. It was if I have an example like negative 2 into the bracket of x minus 3, correct? Some people, what happens is, well, they see that negative 2 over there, and I say, all right, I'm going to follow the same exact model, right? Take this number inside this bracket. So it's going to be negative 2, x, and then 2 times 3 is negative 6. Very good. Yeah, very good. Because you got to remember, when we are distributing this number inside the bracket, I'm taking the whole thing in there. Hence, I have a negative 2x here. Then I'll end up with a negative 2 times negative 3. Negative times negative is a positive, and 2 times 3 is just 6. So I still write this as the mistaken one here, and I write it with red so you guys realize. And I point it out like this. I say, okay, this needs to be a positive. What is another mistake that people do? Well, this was the first form, right? The second form that we had, it was examples of, well, we had a bracket x plus a number to the power. Do you remember that one? What does it essentially mean when we take numbers to the power? So as I say, side note here, I have a side note, very quick side note. What does it even mean when I say any number or anything, 2 to the power of 2? What does that mean? It means 2 times itself twice, yes? 2 times 2. What does it mean if I say a plus, let me just keep it simple first, right? So what does it mean if I say it's 2 to the power of 2? Another simple example would be what? B to the power of 2. What does that mean? B times B, correct, very good. So whatever is in here is getting to the power of 2, is going to the power of 2, is getting multiplied by itself, right? Why should that be any different when I have a bracket? A bracket, it means everything that is here, which is x plus a, is getting multiplied by itself, x plus a, right? Yes, they know.
We also write x in power 2 plus a to power
That's not the same thing. I'll show you why it's not the same thing, okay? And exactly, that's the problem, right? So I write the answer. This is the correct working out, but we are going through mistakes. So let's say key mistake number 2, right? Number 2. And exactly what Daniel said. This is what people do. What do? They say, all right, I'm not going to go through the procedure of what we just talked about here. I'm just going to go straight away and say, well, this is x squared plus, let's say this is 3, right? And put 3 there. Well, it's x squared plus 3 squared, therefore I have x squared plus 9. Which is wrong, right? So I say, cool, this one is not right, incorrect procedure, because I didn't go through, apologies for getting violent over there, knocking the camera, right? Cool. I got a lot of editing to do with this video, yeah? All right, so that situation is not obviously going to give me the right answer. So what do? Well, what I said was the correct way, so this is not going to happen, that's the second common mistake, but the correct way is for us to go ahead and say, is following the same principle, right? The same principle as if I go, whatever is in the bracket to the power of 2 is x plus 3 times x plus 3, right? Now I have to use my distributive law and expand the brackets. Now we will go back into this, but just for now, this is called a rainbow model, or some other math books they call it foiling. It's a really, really old technique to expand 2 brackets like that, right? So if I want to write it straight away, I can just easily say, okay, well, this is the setup, yes? This is the setup. And I go, okay, I need to go, that multiply x, well, it becomes x squared. Then I go, x times 3 will become positive 3x. Then I have to move 3 inside the other bracket. So I go 3x, another 3x, plus what? 9. Now I end up with x squared, and I'm going to collect like terms. See? I have like terms, x is here. So how many x's do you have? 3 plus 3 is 6x. Excellent. Equal plus 9. Now, this is the answer compared to what Daniel said over here. Right? Very good. Okay. If you're taking notes, you need to keep up with me because I'm going to be fast. Otherwise, it's all good. All right. Yeah. There you go. Okay. So let's go through another one. All right? Another one of these. I will write a third one. A third example, I'll write it as x minus 2 and then x plus 2. Okay. Well, if that's the case, should I not just follow the same model? So I follow the same model and I go, I need to go multiply this, and then I take that inside, then I take this one inside, and I do that as well. So this will look like something like x squared, and if I want to do it in my head very quickly, plus 4x minus 4. Are you happy with this? Happy as ever? Helen, what's wrong? Bye. Are you happy with this? With this situation? Yes. Be happy? All right, let's expand it. Let's expand it. Just to shatter your dreams, this is not correct. Why? Because look, I need to expand it, right? Follow the procedure, rainbow model. I go x times x is x squared. So I say, well, incorrect. And then over here, I will say the correct way. And I say key mistake number 3, right? X times x is x squared. Pardon? No, never mind. X times x is x squared. Well, x times 2 is plus 2x. Now it's a negative 2. Wow. Right? Do you know why? Because same story. Look here. Right? So I go back to this. Yeah. So Right here, what I have is now I need to move the whole negative 2 inside this bracket. So I got negative 2 times x is actually negative 2x. And after that is a negative 4. So which one was wrong? Because if I collect like terms here, which is x and x, 2 minus 2 is 0. 0x. I have no x's left. What I do have left is x squared plus 0x, which is subsequently 0, minus 4. I'll end up with the final answer of x squared minus 4, which is correct. This compare to this. See? All right, cool. Let's go another one. So common key or key mistake number 4. What do we have? I have this example here, 5 minus 3x minus 1 to the, and that's it, sorry. Yeah? So what do I do here? Well, I think you can easily see that this is actually 5 minus 3 is 2, and then I have minus 3, and it's actually minus 3x, right? I'm done. Just take a really good look at it, right? Is that good? You happy with this?
Yeah.
Really?
No. How did you get 3x? It should be 2 and then 2 bracket opens x minus 1. So it's delivery minus 2.
Very good. What do I do? Look, well, obviously, again, once again, we're going through mistakes. Yeah, even if you don't know your math, you know the first answer is going to be wrong. Come on. Yeah? All right, cool. So that's not right. What did I do here? Well, in my head, I went 5 minus 3 is 2, and then 3 times negative 1 is actually, oh, whoa, I don't even know what I've done here, right? Let's go through the procedure. What is the procedure? Well, 5 is over here, and 5 is getting taken away from, or 3x minus 1 is getting taken away from 5. But I know that over here, I have a similar example. So right here, look, up to this point, that section is exactly the same as this example up here that we've done. Look, isn't it? Isn't it? Yes? So what is stopping me from following the same model? So I go ahead and say, cool, I'll write 5 down there. I'm just going to leave it for now and deal with this situation right now. I'm taking negative 3x into this bracket. So I go, well, negative 3 times x is negative 3x. Negative 3 times negative 1 is what? Negative times negative. It's a positive, and it's positive 3. What do I end up with now? It's actually 5. There's no like terms for x, right? There's nothing there. But there's 5 plus 3 is 8. 8. Minus, what do I have left from x's? Negative 3, right? See? Negative 3x. This is correct. That answer compare to this answer. Last one. I'll leave this up here. Common mistake or key mistake number 5. I have again 2 brackets, x plus 8, x plus 3 actually, and x plus 5. Cool. Well, straight away I can see I'm really good with my algebra. I'm going to go x times x is x squared. Very good. Then I have 3 and 5 is 3, actually is 8x. And then 3 and 5 also is 8. And I'm done. How's that?
No.
Why not?
Is it 15?
Let's follow the procedure, right? X plus 3, x plus 5. Obviously, you can imagine that this is not right. What do I do then? Well, rainbow model says that I need to take x's at a time, and then I need to take 3 in the other bracket at a time. So I got x times x is x squared. Very good. Plus x times 5 is 5x. And then 3. 3 times x is 3x. And this is all positive, right? I don't need to think about it too much. 3 times 5 is beautiful. Now I need to go collect like terms. Well, the only like term I see is x. So I can write x squared plus 5 plus 3x is 8x plus 15. This is the right answer over here. I will leave these on your e-learn as lesson notes. I'm going to number these lesson notes number 1 over here. Very good. I'm waiting. So Having to go, we went through the mistakes, the key mistakes. I'm going to quickly switch back to our actual lesson very quickly. Just write down the structure for expanding and the structure for factorizing. So that actually is going to help us to transit into our main learning goal, which is factorizing that form of quadratic equations. And in case you guys don't know what a quadratic is just this 2 here. So it's actually the x squared that makes this a quadratic. And that's what it actually means. That's it. That's the only thing you need to know so far. Yeah? Cool? Yeah? You look stunned a little bit. Feel a bit. No? All good? Okay, cool. All right, I'll leave this up here for people that are trying to catch up. So you can catch up. And I start a new page down the bottom here. Yeah? Like this. Need more room. All right. So very quickly, I'm going to write whatever we talked about, everything that we talked about in our expanding of the brackets. Very quickly, I'm going to say, well, first of all, we have, well, the like terms shouldn't really be a problem anymore for us in our level, right? You know which one is like term, which one is not like terms, right? Like terms, yes? All good? So I'm going to go straight into our distributive law. So these are the key points of our review. The distributive law, which is our first step over there when we started off. It was in the form of A, B plus C equals, and I said I've got the rainbow format, right? The rainbow or foiling or expanding format. So I will go A times B is AB plus A times C, and I'm done with that form, right? So what if I have A to the bracket B minus C? Then what do? Well, it's the same story, right? I take A inside the bracket. I got A times B and then A times C, but A times B is very good. A times B is AB. Because I have a negative sign over there, is A times negative C or negative AC. See how it works? Very good. Cool. Let's keep going with the other expansion of brackets as well. Before, we had this form as well, right? We had, if I have a negative number, and I'm going to write it here, in this section here. So over here, I have, let's say I have a negative A times B plus C. What happens then? Well, I'm taking the same exact procedure. I'm going through negative A times B. What is it? Negative AB. Beautiful. Negative A times C is? Okay, hang on. AC you said, right? What sign? Negative. What is negative times positive? It's a negative. Very good. Right? Good. Hang on. One more. Minus A times B minus C. Then what? Isn't that the same situation? So what do you have? Negative AB. And then, very good. Positive what? AC. Good. All right. Now we're getting somewhere, yeah? Okay. Let's go down here, and I'm going to look at what we did in our other example, and I'll show you which one I'm talking about. We did this example right here, which we call a perfect square, and I'm going to write it down. So we have a perfect square situation. All right, perfect square. And if you, in case you're wondering where the term perfect square comes from, it comes actually from a diagram. It comes from a diagram. I haven't taught you how to do it with a diagram model, but if the time allows, I will show it to you this lesson. Otherwise, we'll leave it for next one. But the perfect square situation is when you go ahead and say, for example, if I got A plus B squared, what this means is actually A plus B times itself, right? A plus B. And now look, what I have here is nothing But the same model, right? It's the same model except that I got one extra polynomial to work with. Therefore, I'm just going to take this inside that bracket one at a time. So this will look like what? A times A is what?
A squared.
Very good. Plus A times B. Plus, down the bottom, B times A is what? Well, BA is the same as AB, isn't it?
Yes.
Same thing, right? AB again. Plus B squared. What like terms do you see?
AB.
How many ABs do you have? Two ABs plus B squared plus A squared. Done. Let's do one more for the negative and then we move on, yeah? Okay, what happens here then? What does that mean, Vanessa? How do I write this one? The bracket. Times it by itself, very good. A minus B squared, B times and A minus B. And I'll separate these by this line. Okay, so what happens here? Can you walk me through this one? Same situation, right? I have the same model, yes. Okay, hang on. A times what? Very good. Then A times, and what would that give you? A times B, what would that give you? AB, what sign? Plus, isn't it? Plus, isn't it? Negative? Hang on. Good. That's good. That's good. Wait. Eyes up here. Look. A. Was my head blocking the projector the whole time? No? Okay, good. A times A, which is A squared. Perfect, right? Now I go A times negative B. So it's a positive times negative. What's the sign? What should be the sign? Negative AB, right? Right. Let's keep going. So now this time is negative B times A, positive A. What's the sign?
Negative.
What's the... Very good. Last one is what? We know it's B squared, right? Is it plus or minus? Very good. How many like terms do you see? So I have what? How many ABs do I have? Is it negative or positive? Very good. Negative 2. Who said positive? Who said positive? It's negative AB minus AB, right? Same way, look, side note, right? Side note. Same way as if I said negative 2 minus 2, what would be the result? Yeah. Same deal here, negative AB plus B squared. Very good. Okay, well, that's almost done. We're almost done. What about the last one? So I go maybe start with 1. Oh no, sorry. Leave it. What about the last one? Last one is this. Watch this. Oh, sorry. Thank you. Yep. My bad. Last one, but not least one. We've done this already. We know what the answer is, right? Here, I'll show you. Look. This is what we did. Isn't that what we did? Look. Maybe possibly. The answer at the bottom was what? X squared minus 4. And I want you guys to start remembering these patterns from now on, yeah? Because if I have the same exact bracket, it's the same exact thing, but the sign in the middle is opposite, see? You see, it's a negative 2 here, it's a 2 here. If that happens, then I know that I'm allowed to go straight away to my answer, x squared minus 4, because I've proved it that this is going to work. Now, I'm gonna generalize this, yes? I'm gonna make a formula out of this. So over here, I'm gonna follow the same procedure. So I go a times a times negative b, then b, and then take a b inside. Yeah? Can someone walk me through this, David? A times a is a squared. A times negative b is what? Negative ab. Now, b times a is what? Very good. Plus ab or ba, same thing. And then what? Take b squared. Very good. Now look. Watch this, watch this. Watch this. That and that goes away. 0. I'll end up with what? A squared minus b squared. That's it. Done. Yeah, very good. All right. Yes.
So you could have done that from the start, like you didn't have to expand it.
No, we don't have to. But I just wanted to show you that it works every time, yeah? Okay, now, what I want to do, I want to just quickly give you a quick break for 2 minutes, and we'll get back into this one again, okay? So 2 minutes. All right, let's get it started again. I've already started. I don't know about you guys. So, okay. So let's go with our. All right, let's get started with our second side goal. We're going to look at factorizing now. We've done the expanding, which, can you hear me fine? Is that coming through the speakers? Not really? Hello? Testing. Come. That's good enough for recording. That's good enough. All right. We've done the factorizing part. We've done the expansion part, and the expansion is nothing. The factorizing is nothing but. Wait. I will cut these bits out of the video. Factorizing is nothing but the opposite of expansion. So if I expand in this form, and we had, for example, very simple situation that we had was very beginning. It was x times a plus b. If I expand it in this form, I should write it this way. Should write over here. That I'm going to expand this, and we all know what this is going to look like. What's the answer when I expand this? Very good. Ax or xa doesn't really matter, plus bx. Very good. Now, factorizing is nothing but going from this form, or I should write it, I should draw my arrow here in the middle so you don't think that it's only going to be one polynomial that is moving. This is actually factorizing, right? Factorize. So basically, it's a cycle you can actually establish. All right, very good. So let's go through some examples and find out what we can do. And I want to actually start with a more difficult situation than this. Like, this is too simple, right? Because I can see what is the common factor that these two terms are sharing. What is the common factor? Is x. Yeah, good. So if I put x behind the bracket, then I'll have what a plus b is inside the bracket. So I'm going to do is I'm going to go a bit full speed now. So you got to have to keep up, yeah? So I go, okay, factorize. And this is another side quick letting go. I'm going to go factorize, and I say, okay, well, I need factorizing expression I need the common factors, right? And even more importantly, I need the highest common factor between those two. And I'll tell you what happens. I'll give you an example. All right, cool. I have an example of, so I'm just going to just write this. I said factorize expressions with common factor, right? That's in the situation that I do have common factors and I can see them. It's easy, right? So I need to take out that common factor. I'll give you an example. So if we have minus 5x and minus 20, these two, I want to write them in a form of something here times something here, and then either plus or minus in the middle, right? I'm factorizing this. So what is the common factors of negative 5x and negative 20?
5.
Is it negative 5? Maybe negative 5, right? So let's see what happens if I put negative 5 here. If I put negative 5 here, well, from that situation, I'll have x left, because that's what we do, right? Very good. And then plus or minus? Plus, because I need it to be negative here, plus 4. Okay? For the people that did not follow, this is what I've done. Look, I have two terms, right? I have negative 5x, and I have negative 20. Okay. I go find the highest common factor of these two. What are the factors here? Well, the factors are 5 and x here, nothing else, maybe 1. And then over here, what do I have? I have 2, 10, what else? 5, 4, what else? That's it? 1. What is the highest common factor between these two?
5.
Very good. Now, what do I need to do? So I'm going to write this step by step. Step 1 is find the highest common factor. Find the h common factor. Step 2, to factorize, is to write your common factor. Write your common factor. And I'll show you why this could be actually written in two different forms, right? Your common factor. I should say HCF. Write your highest common factor, and then open up a bracket, right? Behind the bracket, the bracket. And this is a step that I've done. I said, okay, hang on. Well, I said the highest common factor is 5, but before you showed us that I can put negative 5 as well. Let's see how this is different. I'll show you. Well, let's follow these steps now. I said, okay, well, highest common factor is 5, isn't it? Then open up the bracket. Very good. Leave it. Number 3 is I need to go divide each term. So to be able to take these terms inside the bracket, so to take terms inside the bracket, they need to get divided by highest common factor, right? Well, think about it this way. Think about it like a filter, right? I'm going to grab this term, negative 5x, move up, negative 5x, and go through this filter of 5, right? Yes? So what happens if I go through this filter of 5? It's telling me to divide, right? Well, if I go negative 5x divide by 5, what do I have left? 1. Minus x. Very good. Done. Then write it inside the bracket. Now, what about the other term? Negative 20 divided by 5. What do I have? Here, look. Negative 20 divided by 5. What do you have? 4. Positive or negative? Therefore, I have negative 4. Now, look at this. We factorized the same term, and because this was a bit complicated, because they both had negative sign, right? We factorized them in actually two different ways. And they're both correct, because in this situation, I said, well, negative 5 is the common factor. This is correct. But in this situation, I didn't take the factor of negative behind the bracket. I left it as a positive. Is again correct. The aim or our goal was to go from the expanded form into the factorized form, and we did. So I'm going to write the whole thing here. Negative 5x minus 20 if I go factorize from the other end. So if I write it here, 5 times negative x minus 4. This is when I go expand. And this is where I go factorize, right? Factorize. And both are correct. That's why I can write one of them, that's fine. Yeah? And the other form, again, same deal. I can write this one as well, negative 5x plus 4. Same deal. Over here I have, and I can write an equal sign here, minus 5x minus 20. Now, this is factorize it. Which one of these do you think look better? Which one do you prefer? That one with 2 negatives inside the bracket, or this one behind this? I think this second one is a bit more elegant, right? It looks a bit neater, more sophisticated, if you may, right? And this way we go expand, expand. All right. Well, now we have an idea, right? Okay. I want to show you something else. If I have, and this is just very quickly, right? And I think we're going to end our lesson here. We're not going to go through quadratics today. We're not going to have time. I'm going to leave you to do some exercises on your own for 10 minutes. But just one last challenge. That's very quick. And the people that already know the answer, please don't answer. I don't need you to show off. Other people here, I need to know, if I have a situation as x squared minus 16, could you, and you're allowed to go back over your notes, can you factorize this for me? When I say factorize, it means write it in factors, right? Write as a multiply of 2 brackets, like we did here, or a number and a bracket. Can you straight away factorize this for me without even having to do anything? Right? If you go back to your expanding notes, do you have the answer for me? Daniel?
Is it like in 1 bracket, or you mean 2 brackets?
It's going to be 2 brackets, obviously. Yeah, yeah.
I only got 1 bracket.
It's a challenge. This one is a challenge one. Do you know Hamza? Do you know how to do this? You're thinking? Go back over your notes. That's my hints to you.
X minus 4, x plus 4.
Very good. Very good. I think you were about to say that, yeah? Do you see the pattern? Yeah? Do you see the pattern? So if I go over here, this is factorize, and if I go this other way, it's expanding, isn't it? Look. Expanding. All right. All right, guys. End of video. I will see you again in maybe another video if I'm not sick of doing this.